Morning, dear students. How are you all? I welcome you to this again a new session, new uh, live session for CA final, Advanced Financial Management, wherein we are discussing right now the topic of portfolio management. Right. Good morning, Abrakesh. Good morning, Danya. Good morning, Karthik. Nisha, Sahil. Very good morning. Okay, so we have started the subject long back, and this particular topic also we have started like in the last session, where we just got an introduction about the topic and some basic things about risk and return. Now it's time for us today to take it ahead with more advanced level of discussion that will be undertaken. So let me just quickly recap what we have done till now, and then probably we'll take up the next part. So first we understood how do we compute the return from a security, which will be, return from a security will be simply computed as current price minus previous price plus the amount of dividend that we are receiving to divide it by P0. Now to calculate the expected return means the return that we are expecting in the upcoming year. You can say expected return will be maybe the weighted average of the returns that are likely to occur in the future, which is when a probabilistic data is given. So we can take the expected return to be simply summation of probability into return. And also we computed the risk involved in such security by calculating the standard deviation. Standard deviation is computed as square root of summation of P into R minus expected return of R, right? Expected value of R the whole square. That gave us the standard deviation. Then if we have a data which is historical in nature, so we can definitely calculate the returns, and then we need to also take the square of the return, so that expected return will be nothing but the average of the historical returns, and standard deviation of the returns will be computed as square root of summation of R square upon N minus expected return the whole square. Okay. Now this standard deviation number can be computed by using the other method also, which is summation of x minus x bar the whole square upon n. Okay. Then we were trying to work out with two set of values between two set of returns between two securities x and y. So we computed expected return of x and y and the standard deviation of x and y. So we've computed both of them, and then we thought, let's think of it as a portfolio. Let's just think of it as a portfolio, so that we'll be able to compute the risk and the return for the portfolio as such. So we created a portfolio with 60% weightage to X and 40% weightage to Y. And we computed the historical portfolio returns by simply taking 60% of X and 40% of Y. The average or the expected portfolio return, we computed it as 444.8 divided by 5, which is the average. And alternatively, we also check that if we just know the expected return of X and Y without any information about what is happening in the historical return, we can simply take the weighted average and the answer definitely matches. But the same thing was not happening when we were computing the standard deviation. So when we were computing the standard deviation, the same thing was not happening, and we were finding that there was some deviation, some difference between the standard deviation of the portfolio and standard deviation of portfolio using the historical returns and the standard deviation just taking the weighted average. Then I gave you another example wherein we were able to connect, and we found that the expected portfolio standard deviation was exactly same as the weighted average of the standard deviations of the two securities. So that was matching over here. And I had told the reason for this. Do you remember the reason for this? Yes. Do you remember the reason why this was the case. I haven't explained it fully, but I think I have given the reason. What was the reason for this, guys? It was a suspense, sir. Yes, it was a suspense, but then I named that suspense. I had named that suspense. What was the name of that suspense? Yeah. What was the name of that suspense? Name of the suspense is. Do you remember? I had said, I have informed you that the reason is this, and why is that reason that we were supposed to be discussing in today's session. We'll be definitely taking up that discussion. But what was the name of the suspense that we are talking of? What's the name of the suspense? Yeah, let me check. Someone is answering there. Markovitch theory. No, Markovitch. The Markovitch theory is what we are learning right now. But what was the reason that both the numbers of standard deviation were matching in one case and it was not matching in the other case? Yes, it was correlation, right? I have said that this is due to the correlation between the two securities. Right? This was due to the correlation between the two securities, if you can recall. Right? So correlation actually plays a role in determining the portfolio standard deviation when two or more securities are involved. Okay. So when we have two or more securities, portfolio is the correlation between the securities is what plays a role to give you the value of the standard deviation of the portfolio. Now, so to understand how correlation plays a role, we need to first understand how to compute the correlation. Do we remember correlation from our foundation days, from our CA foundation days, or maybe from your 11th and 12th standard days? Okay. So let me just recollect, let me just tell you what is this correlation and how do we really compute it. So let me just calculate the correlation for these two values between x and y. So correlation between x and y, let's try to compute it. How do we compute the correlation? By the way, what is correlation? Correlation is the degree of relationship or the degree of linear relationship between two variables. Okay, so between two variables, what is the degree of relation? That's the correlation. Now let me just plot a graph, and looking at the graph, just look at this graph, and from this graph, can you really say what is the degree of correlation? I mean, do you think there is a broadly a positive correlation or a negative correlation? What do you feel? Is there a positive correlation or negative correlation over here? Looking at the graph, can I say more or less it seems to be positive because the values are, concentrated over here, where I see that a higher value of y is obviously warranted by higher value of x, right? But how do we really define this measure of correlation as in numerical terms? So for that, let me just write a formula for the correlation here, guys. Correlation is computed in case of historical data like this. Correlation is computed as covariance between x and y upon standard deviation of x and standard deviation of y. Okay, so we have to get deep dived into some sort of statistics to understand the portfolio numbers. So correlation is covariance between x and y upon standard deviation of x upon standard deviation of y. By the way, the covariance term is computed as covariance between x and y is computed as summation of x minus x bar into y minus y bar upon n. So if we just substitute the covariance terms over here, this will be summation of x minus x bar, y minus y bar upon n, and then this whole thing divided by standard deviation of x. We know the formula for standard deviation of x. It is square root of summation x minus x bar square upon n, and then square root of summation y minus y bar square upon n. Okay. Now we can definitely say from here that this n and the denominator n gets cancelled. And what we have is summation of x minus x bar, y minus y bar, the whole divided by root of summation x minus x bar square and root of summation y minus y bar square. I can actually simplify this further, open the brackets, right? And we come up with a more concise or more implementable formula, which is summation of, it has to be n summation xy minus summation x into summation y upon root of n summation x square minus summation x the whole square, and there that same applies for even y. It will be n summation y square minus summation y the whole square. Okay, so n summation x square minus summation x the whole square, and same goes with y also. So why did I say that this is more implementable? Because otherwise, if you are trying to use this formula, you need to get obviously x bar, y bar, you need to multiply them. Now this, if it comes out to be in decimal, it becomes a really difficult task for us to implement it, right? So this is more implementable formula, wherein we already know the values of x and y. We can say this is 42 and this is 49. Right? So this is already what we have, the summation. So as far as this formula is concerned, we know what is summation x, we know what is summation y, right? So what additional columns do I need to add in this data so that I can calculate the correlation base? What additional columns should I add so that I can calculate the correlation? Yes, what additional columns should I add? xy.
xy.
Okay. And one will be, of course, xy. What other column? Look at this, xy and one more column. Yeah, x square and y square, right guys? So let us put this xy, x square and y square. So xy will be 12 into 13. I get the values, right? Just wait, students. This question is what I'm going to do. The next question I'll give you a chance to solve, okay? So we got xy, then x square will be x multiplied by x itself. And then we will take a total. Y square will be y multiplied by y. And then we take a total of it. So we have x, y, xy, x square, and y square. So what we need to do is, let's just substitute over here to get the correlation terms. So the substitution will goes as n summation xy. So n is basically 5 terms. So this is going to be 5 multiplied by summation xy. Summation xy is 550 minus summation x into summation y, which is 42 into 49. This is 42 multiplied by 49. And then this is going to be divided by square root of n summation x square. When we say n summation x square, it is n is 5 multiplied by summation x square. So summation x square is 694. 694. So minus summation x the whole square. Summation x is 42. This is 42 square. Okay, so let me do one thing. It becomes a bit of tedious task to write. Let me value it over here. So this is like n is 5 into summation xy 550 minus summation x is 42 into 49, the whole divided by square root of n summation x square. N summation x square will be 5 into 694. This is 5 into 694 minus summation x square. So summation x the whole square is 42 square. This is minus 42 square. Stating problem. Yeah, so this is 5 into 550 minus summation x is 42 into 49, then the whole thing divided by square root of n is again 5 into summation x square, which is 694 minus summation x the whole square, which is 42 square, and then this is summation of, root of again 5 into 555, which is n summation y square minus 49 square. So if we just solve this, what's the value of correlation, guys? Once we solve this, what's the value of correlation we are getting? And say it is 5 into 550. Yeah, so this will be like 5 into 550 minus 42 into 49. This is the numerator. Now, denominator will be square root of 5 into 694 minus 42 squared. This is one part. The other part is square root of 5 multiplied by 555 minus 49 square. Right. So we can say that correlation now is essentially working out to be 692 divided by both the numbers in multiplication. So we get the correlation value to be 0.87. Okay, so 0.87 is the correlation value that we get on substituting these functions. So 0.87, it means there is a 87% correlation between x and y. Okay, so there is 87% correlation or linear correlation between x and y. Now, would you like to calculate the correlation similarly using this data? Take this data, okay, and then just try to compute the correlation. Can you do this? I'll just keep the formula ready for you. Yeah. Can you solve this? Can you solve the correlation? Get the value of correlation, guys, between x and y? Yes. Shall quickly solve it. Maybe a couple of minutes for you. You just need to create columns of xy, x square, and y square. Compute the columns and substitute in this formula and give me the value of correlation, guys. Yes. So x square, then y square. Okay. So here are the correlation values. You can just apply the same formula. Three multiplied by summation xy minus summation x into summation y. Right. Then denominator, you can say it is square root of x square summation square root of 3 multiplied by summation y square Let's check. If we're getting the correlation value as 1 for this data, is the correlation value equal to 1?
Sir, one correlation one means that both the data are going in same direction with the same
Yes.
degree.
Yes.
But here it is not going the same degree. 10, 13, and 8. And another is 15, 21, and 13. I mean, it should be some
10,
proportions.
13, and 9, 15, 21, and 30. There is a linear relation between x and y. When you say they move in the same direction, of course, with the same direction, and there has to be a linear relation. So if you could recall a bit of foundation logical reasoning, we had something called as relation between numbers. So if you check over here, verify if, y is, this entire data is modeled on the fact that you can say y is, you'll observe it is 2x minus 5. Just check all the values of y are connected by this pattern, 2x minus 5. So there is a linear relation. Correct? Can you see?
Okay. Yes, sir.
They are satisfying this linear equation, and therefore you will say that the correlation is 1. Because if I just try to plot this on a graph also, what we will observe is, you can see they are all, all the 3 data points are in a straight line, which was not the case in the previous example.
Yes. Okay.
Therefore, whenever the points are such that they are in a linear fashion, you'll find that the correlation is always 1. Okay.
Okay.
Just check, everyone. Are we getting this correlation of 1? Others? Karthik? Ginny? Are you getting the correlation as 1? Yep. Anila? Okay. So we're all getting the correlation 1. So the 2 examples that we took in the previous class, in the first example, we're getting a correlation of 0.87, and in the second example, we're getting a correlation of 1. Now, let me just open it for you. In the second example, we found that the alternative method was giving us the same portfolio risk. The alternative method was actually giving us the same portfolio risk as the long cut method, or the historical portfolio return method. But that was not the case with the first example. Now, why is that? We can observe that in the first example, what's the correlation between the returns? In the first example, the correlation between the returns is, first example, the correlation between the returns was 0.87, whereas in the second example, it is perfectly 1. Now, how is this, entire mathematics really working around? So let me just quickly work it for you by way of something called as, deriving that formula which was given by Markowitz. Okay. So let me just do it for you quickly. See, standard deviation of portfolio. When we were calculating standard deviation of portfolio, let me do one thing. Let me take the square of it, so that we need not put the square rooting again and again. That was actually computed as standard deviation of the returns of the portfolio. So if we look at how we were computing the standard returns of the portfolio, were computed as weight of X into standard deviation of X, the return of X, plus weight of Y into return of Y. So this portfolio, when we were computing the standard deviation of portfolio, this was computed on a similar lines, that it is summation of return of portfolio square upon n minus expected return of portfolio square. Right? Is this equation understood to you? When we are computing the standard deviation of portfolio, this is computed as what? Normal, like standard deviation of X. Standard deviation of X was what? Summation X square upon n minus X bar. Right, guys? Is this equation clear to you? Then only I can derive it with further part. Is this equation clear to you? Everyone? Is this equation clear to you, everyone? Yes? Okay. So now let me just substitute certain things. Like, how did we compute the return of portfolio? How did we compute the return of portfolio over here, guys? So return of portfolio was essentially, weight of X into return of X plus weight of Y into return of Y. Correct, guys? It was weight of X into return of X plus weight of Y into return of Y. So let me just say over here that this is nothing but weight of X into X plus weight of Y into Y. So wherever I see RP, I can substitute over here that this is summation of weight of x into x plus weight of y into y, right? So this is the whole square divided by n minus. Now, how did we get the expected return? Expected return was simply summation of return of portfolio upon n, and this was squaring it fully. So this is going to be summation of weight of x into x plus weight of y into y, the whole square upon n minus return of portfolio. Again, return of portfolio, let me just substitute it. This will be, weight of x into x plus weight of y into y, the whole upon n square. Okay. Now, of course, this is going to be summation of the entire part. So this is like we need to apply the summation over here, and then this entire expression was square, right? And then if you just solve it and open up the brackets, like here we can say this particular portion, which is weight of x into x plus weight of y into y, the whole square. If you expand it and we have a square outside, that will be weight of x square into x square, which is simply a plus b the whole square, plus weight of y square into y square. So plus 2 into weight of x, weight of y, x and y. 2 into weight of x, weight of y, and then x and y, and then this whole thing divided by n minus, let's take this summation that we have as inside. We have this particular summation of weight of x and x. So let me just take the summation inside. And if you could remember a bit of mathematics, the summation doesn't apply on the constant rules. So you take the weight of x outside, that will be summation x plus weight of y outside, and then summation y, right? And this whole thing divided by n whole square. Okay. If you're going to solve this, now I'm not going to solve it fully for you, but when you're going to solve this, essentially the entire portion, when you're going to solve it, what are we going to get as the standard deviation of portfolio? Okay, you can just solve it, do the manipulation as a part of your homework and try it at home. Finally, the variance of portfolio will work out to be somewhat like this: weight of x square into standard deviation of x square plus weight of y square into standard deviation of y square plus 2 into weight of x, weight of y into covariance between x and y. This is what will be the final result of this derivation. I can also write it in another way. In one of the ways that we can say is that, correlation is covariance between x and y upon standard deviation of x, standard deviation of y. So what can I write this covariance as? Try to connect both the formulae side by side. What can I write this, covariance of x and y? Can I say this implies that covariance between x and y is essentially correlation between x and y multiplied by standard deviation of x, standard deviation of y. So we can say variance of portfolio is weight of x square into standard deviation of x square plus weight of y square into standard deviation of y square plus 2 into weight of x, weight of y, standard deviation of x, standard deviation of y, and then correlation between x and y. Right? So this is what is the formula given by Markowitz for calculating the portfolio variance or portfolio risk. Right? This is nothing but derived from the same part as we have written over here. Right? So it's derived from the this particular portion, this particular formula that we have. Like if you take the summation inside, right? Take the summation inside, weight square of opposite other side, do a bit of manipulation, you will be getting this value. You will see weight of x square, from here and also from here, that gets common, and then you will have standard deviation of x square. Okay, so I'm not just going into derivation part because that's not a part of our syllabus, but I'll just give you a reasoning or a logic as to what this particular variance of portfolio is computed as. So these two are the formulae given to us by Markowitz to compute the variance of the portfolio. Okay, now just think of a scenario, where suppose R is, +1. So if we have a scenario where correlation between x and y is 1, so how would the variance of portfolio be? Variance of portfolio will be simply weight of x square into variance of x plus weight of y square into variance of y plus 2 into weight of x, weight of y, standard deviation of x, standard deviation of y, and this will be 1. Now, if this is 1, what will be the final thing? It will be like, weight of x square into standard deviation of x square plus weight of y square into standard deviation of y square plus 2 into weight of x, weight of y, standard deviation of x, standard deviation of y. If you look at this expression, does it look similar to a plus b the whole square? Right, guys? Does it look similar to a plus b the whole square? Like this particular portion is, a square. This particular portion is b square. And this portion is 2ab. So what can we summarize this variance of portfolio to be? Can I say variance of portfolio will be simply weight of x into standard deviation of x plus weight of y into standard deviation of y, the whole square. So this particular variance of portfolio formula will be applicable only if correlation is +1. Okay. And if the correlation is -1, then the formula will be weight of x into standard deviation of x minus weight of y into standard deviation of y, the whole square, if correlation is -1. Got it, guys? So the original formula is, the first two. These two are the original formula. And if you take R as 1 or -1, then you can shorten the formula by simply using these two formulas. Any of these two. Like if your correlation is +1, you use the first formula. If your correlation is -1, you can use the second formula. Okay. So now, when we were looking at the second case, when we were able to see that, the portfolio standard deviation was matching exactly, the reason being that correlation was +1. The reason being that correlation was +1, and therefore you take a weighted average or you take the expected return or expected standard deviation of the portfolio, answer will be same. But that was not working when we were looking in the first case. Can you tell me why was that not matching? Why was that not matching? Because we got the historical as 6.34 and alternatively we got this as 6.5. This was not matching because of the reason being the correlation. Because the correlation over here between the two securities, in the first case, it was 0.87. It was not 1. Now, if I apply this formula, if I'm going to apply this formula, in the first case, it will match. Let me tell you. Let me show you this one. In the first case, if I apply this formula, anyways, this was the incorrect one. So correct shortcut method is what? Correct shortcut method would be, it will be standard deviation of weight of x square into standard deviation of x square plus weight of y square into standard deviation of y square plus 2 into weight of x, weight of y, standard deviation of x, standard deviation of y, and correlation between x and y. So if we just substitute the values, we should be able to get the answers. So like take a square root of weight of x square. What was the weightage? 0.6. So it will be like 0.6 square multiplied by variance or standard deviation of x square. So we had the standard deviation of x square as 8.26. So 8.26 square plus weight of y square, which was 0.4 square multiplied by standard deviation of y square, which is 3.87 square plus 2 into weight of x is 0.6 into 0.4, weight of x into weight of y, into standard deviation of x into standard deviation of y, into what was the correlation, guys? What was the correlation? 0.84, right? 0.84. What was that number? Correlation? No, so 0.87. Sorry.
0.87. 0.87.
Yes. So it was 0.87. Now you can see it is matching, or maybe some slight difference because of, we have taken like 0.87. If I link it with the correlation value, it will match exactly because we've just taken 2 decimals. Yeah, now you can see it's the same 6.34, and now the values are definitely going to match. Look at this, 6.34 exactly matching with this number. Okay, so the real reason why the simple weighted average of standard deviations is not going to work, it's because the relationship between the two variables, or relation between the return of two securities, in the form of correlation. So that correlation is playing a role to change the portfolio standard deviation. Okay, so the correlation is actually playing a role to change the portfolio standard deviation, so that you will be able to understand that the portfolio standard deviation is not computed only on the basis of individual standard deviations, but also the way or the direction in which the returns of the securities are moving. Okay, lesser the correlation, you can create a portfolio with lesser amount of standard deviation. Okay, fine. Is it clear? Is this formula and the method clear, everyone? Yep.
Sir, Prakash.
Yeah.
So can you, go back to the last calculations which you showed? For matching the both 6.34.
This one?
Formula is weight of r square x square. So
yes.
0.6 into what x square is to be replaced. No, to be submitted. Insert.
No, it is weight of x square. So weight is 0.6. So 0.6 square.
Acha, okay. Fine.
There's a square on the weightage,
yes.
not on x.
Yes. Okay. Thank you.
Yeah. Okay, and this was our correlation, which is 0.87. Okay, so the whole idea is we need to follow this particular formula for calculating the portfolio risk. Simple. If the correlation is 1, you substitute it over here. If the correlation is -1, you substitute over here. If the correlation is anything else, you substitute over here, and you will get the portfolio standard deviation. Okay. Now, in the same thing, if we are understanding what is going to happen to the values, let me just create a Excel thing just for our understanding. Okay. Like in this case, we had computed the standard deviation and the weightage, standard deviation and the correlation, everything is computed. Let me take an example to understand it in a better way. Suppose there are two securities, A and B. Okay, there are two securities, A and B, and I say that they definitely have got their own set of standard deviations. Suppose we have the standard deviations to be let's say 10 and 13. Okay, 10% and 13% are the standard deviations of these two securities. Okay, now we'll also define a correlation between them and also the returns. We talk of the return, of course, in percentage terms. Let's say A is providing us a return of 12% and B is providing us a return of just change the format. Yeah. So A is providing us a return of, let's say, 12% and B is giving us a return of, suppose, 14%. Okay. And we definitely have the correlation between both of them. So let's say, let us assume the initial correlation to be 0.2. So this is just what an example I'm taking for our understanding. We're going to observe a really interesting phenomenon of portfolio by way of graph, and you really like it. See, so standard deviations, we say it is 10 and 13, and returns are 12 and 14, and correlation is 0.2. Now let me create certain portfolios. So like portfolio number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8. Right. So we are like looking at 8 different portfolios, and for each of these portfolios, what are we changing is weight of A and weight of B. So we are looking at having multiple values of weights of A and B, and then trying to be more calculative about the risk and the return. So let's say weight of A. Initially, I'm fully invested in security. Let's say B. So I'm fully invested in security A, and the weightage of B will be like 1 minus the weightage of A. So I'm fully invested in security A initially, and then I start mixing. I start churning my portfolio a bit, and I say that weight of A, let's say it becomes 0.9. So we are reducing our weightage. We are reducing our investment in A by 10%, and that 10% is invested in B. Then we keep on changing it 0.8. Then we have 0.2, right? And same way, we can have, let's say, 0.7, and this is 0.3. Can you compute the standard deviation of portfolio? Can you compute the standard deviation of portfolio? Yes. And also return of the portfolio. Can you compute the standard deviation of portfolio and the return of the portfolio? How do we compute the standard deviation of portfolio, guys? Using the same Markowitz formula. So I'll just write the formula here. Standard deviation of portfolio will be square root of weight of A square into standard deviation of A plus weight of B square into standard deviation of B square plus 2 into weight of A, weight of B, standard deviation of A, standard deviation of B, and correlation between A and B. This is what we are supposed to calculate as a standard deviation of portfolio. And how do we get the return of our portfolio? Return of portfolio will be weight of A into return of A plus weight of B into return of B. You can calculate that, right? Correct, guys? So can you just calculate the initial numbers, because rest values I can just drag it easily, but I just want you guys to practice a bit of this formula. Can you calculate this? Like we have the weightage of A, weightage of B, standard deviation of A, standard deviation of B, and the returns along with the correlation between them. Yeah. Can you calculate this? Standard deviation of the portfolio and the return of portfolio. Can we do that, guys? Yes, sure. Get the standard deviation and return portfolio for these 4 numbers, because rest numbers I can drag it easily for you. But I want you to get a hang of this formula before we proceed further. Please try to calculate it, guys. Yeah. So first one, standard deviation of portfolio is very easy since it is only 1. You can simply say that the standard deviation of portfolio will be 10. The return of our portfolio will be also this will be equal to just 12. But it's just one security. Now, when you're adding B to the other security, then we need to apply this formula. So it will be square root of standard deviation of A square into weight of A square plus standard deviation of B square into weight of B square plus 2 into weight of A 2 into weight of A into weight of B into standard deviation of A into standard deviation of B into correlation between A and B. So we can say that standard deviation of the portfolio, check if it's 9.35 for the second portfolio. Is it 9.35 for the second portfolio? Return will be weight of A into return of A plus weight of B into return of B. Return of 12.2%. Yes. Okay, same way, try it out for the third one, guys. Try it out with the third one. Try the third case also, where it is weightage is 0.8 and 0.2. Let's check with the third case. Check with the third case. If you're getting these numbers. Third case is 8.89. Got it? Okay. So now you're good enough to calculate these numbers. Let me just drag it down. And here we get these values. Yep. So are we getting this portfolio risk and return in few cases? Yes. So now here we have this particular schedule for this particular data where we are just trying to change the weightages. We're trying to change the weightages and looking for what are the possible standard deviation and the returns. Now think logically, guys, over here. What is happening? As you are combining A with B, out of these two securities, out of A and B, which one is having a lesser risk and which one is having a greater risk? Which of these two, A and B, is having a lesser risk and which one is having a greater risk? Which security has a higher risk and which security has a lower risk? A is having less risk, right? Because it is having a risk of 10. And B is having a higher risk because it's having a standard deviation of 3. So initially, when we were in portfolio 1, can I say we were invested in a less risk security? Right? We were invested in a less risk security. And when we actually combine the lesser risk security with some quantum of high risk security, right? When I introduce just 10% of blending, 10% of blending with this original portfolio. So we try to mix up a low risk security with a high risk security. So any layman would expect what should happen to the portfolio risk if you are mixing a low risk security with the high risk security. Can I say the risk which was originally 10, it should actually rise. But is it rising? Is the risk increasing, guys? Is the risk increasing by combining a high risk security with a low risk security? Is the risk getting reduced? No, the risk is in fact risk is not rising. In fact, risk is getting reduced because from 10, it is becoming 9.35. Now, what is the reason? Why is the risk getting reduced? Why is the risk getting reduced when you're combining A with B? What is the reason? Because of this correlation value, low correlation. This is a correlation of 0.2. Right? So you can see that there is a fall in the value of the risk, but only up to certain point. You can see that the risk reduces, it keeps on reducing only up to this fifth portfolio. It keeps on reducing only up to this fifth portfolio. And what happens beyond fifth portfolio? If I, let's say, introduce maybe one more portfolio or two more portfolios, with let's say weightage of 0.1 and 0. And if I just apply it here, what do we observe? if I just slowly transition it to more and more weightage of B, I find that up to this particular point, which is weightage of 0.659 and 0.351, we observe that the standard deviation of portfolio is reducing. Beyond that, the portfolio risk starts rising. Correct? So this particular reduction in the standard deviation is happening only and only due to the correlation part. Now, just for example, if I take this correlation as higher, then let's say if I take the correlation as 1, what you will observe is all our values are paste them as values. Okay. So if I take the correlation as 1, you won't find any effect of portfolio risk reduction. Are you able to see any portfolio risk reduction if your correlation is 1? Like when it was 0.2, we observed that it was getting reduced from 10 to 9.35, then to 8.89, then to 8.67, then finally to 8.65, and then it starts rising. But when I take correlation is 1, what do we observe? If your correlation is 1, the standard deviation of portfolio is keeping on rising. It's not reducing anymore. So risk reduction of a portfolio is possible only if risk reduction of the portfolio is possible only if the correlation is lesser than 1, and lower the correlation, the more possibility for you to reduce it. Like for example, if I take the correlation as -1, you can see the portfolio gets reduced substantially to just 1.5, or maybe even lower than that is possible if it takes some other weightage, right? So originally, when our portfolio weight was 0.2, this was what our correlation was 0.2. This was the portfolio standard deviation and the return that we were observing. Now, if I just try to plot these two in the graph, this is what we observe the graph looks like. Look at this graph. And you know what? Right? You know what? This particular correlation value, if I make it like 1, this will become a straight line. See, if I make the correlation value as 0, it will be even more, moving on the other side. Lower the correlation, the graph will be tilting towards the, towards the y-axis. The graph will be tilting towards the y-axis. So I'll just show you. One second. Let it just open. Pulja Simpson. It's not working. Chin tapakare. It worked. Before I said chin tapak tam, it worked. Okay, so correlation of 0, this is what we observe. If I make it as like -0.2, you'll see that the graph shifts even more bits on the other side. If I take it as -0.5, it shifts further to the left side. If it's -0.9, it shifts to the even more extreme. And if I take it as -1, then it further shifts to the left side. So this particular curve, the movement actually depends on the pattern of the curve, or the shape of the curve depends on the correlation. Right? The shape of the curve depends on the correlation. Okay. So lower the correlation, the curve will be on the left side, or I can say the lesser amount of risk can be created. Okay. Right. So now this particular aspect of correlation influencing the shape of the portfolio return and risk curve is what we are trying to cover over here. And the whole idea is that you can reduce the risk of your portfolio. You can reduce the risk of your portfolio if the correlation is lesser than 1. Can we reduce the risk of our portfolio if the correlation between two securities is 1? No, it's not at all possible, because if we have 1, it's just a straight line. If it's like 0.9, still you see some sort of deviation is possible. If it's 0.8, it shifts further. If it's 0.7, it shifts again further. If it's 0.6 or 5, it shifts again further. So we had originally taken it to be like 0.2. So we were able to create a portfolio which was giving us a better return at a lower risk. Now, if I ask you, in this entire set of portfolio, looking at the standard deviation and return of the portfolio, a rational investor will not be investing in certain portfolios. In this entire set, a rational investor will not be investing in certain portfolios. Can you identify which are those portfolios from 1 to 10? From 1 to 10, which portfolios are not at all suitable for any rational investor? Out of these 10 portfolios, which portfolios are definitely not going to be taken up by any rational investor?
First, second, 8, 9, 10.
First, second, third.
8, 9, 10.
No, first, second.
No, not third. First,
third.
second, and no, not third.
Any rational investor is not going to choose the securities 1, 2, 4. 1, 2, 3, 4. Because what is happening over here? You can say the standard deviation of portfolio is reducing. It means the risk is reducing, right? And what's happening to portfolio return? Portfolio return is also rising. You can be a person who would like to invest from 5th to 10th, depending on your risk appetite. Depending on your capability to take risk, you can choose securities from 5th to 10th, but not from 1 to 4. Because from 1 to 4, why would I be really interested in investing in this third portfolio, which is having a risk of 8.89 and a return of 12.4? Instead of that, can't I be just investing in the 5th portfolio, which gives me a higher return at a lower risk? Am I right? Correct.
Agreed, sir.
Right. So from portfolios 1 till 4th, they are not at all suitable for us. Any rational person would not be investing in 1 to 4 securities because they are all providing you returns lesser than 12.68, and they also have a risk higher than our portfolio. So from 5th to 10th, this is like, these are the portfolios which will be selected by persons depending on their risk appetite or depending on their risk taking capacity. So someone who want to take, higher risk, he may go for 8, 9 or 10 portfolio, which is obviously offering a higher return. Someone who is, not looking at very high return, but, he wants to look for a portfolio where, he can get a lower risk. So of course, lower risk means he's going to select this 8.65 standard deviation portfolio, which promises a return of 12.68%. Okay. So these set of 4 securities are not at all suitable for any rational investor. And these securities or these portfolios are said to be inefficient portfolios. They are said to be inefficient portfolios. Now, what is this inefficient portfolio and other aspects? We'll take it up in some time. But the idea is these inefficient portfolios will not be selected by any of our investors. These portfolios will not be selected by any of our investors. Okay. Now, what do you think? This 0.659, 0.341, this is something, weightage which I have assigned randomly and we found it to be the best portfolio to start with? No, there is a formula. This is the optimum portfolio or optimum portfolio. I can say this is the portfolio which gives us a lowest portfolio, lowest risk. So won't we be interested in knowing, sir, how do we get the weightage of this? How do we get the weightage of this particular portfolio or this particular security so that we are getting a portfolio with the lowest possible risk, right? Won't we be really interested in knowing the formula or the method to calculate this weightages so that we can calculate the lowest risk portfolio? Because this is the lowest risk portfolio. So optimum portfolio or lowest risk portfolio, weightage can be computed using a formula. Let me just put that formula in front of you. Or minimum variance, or you can say minimum risk portfolio weights. The formula to calculate the minimum variance risk for portfolio weights is, if you want to calculate the weightage of A, that can be computed as, let me just write it. Weightage of A, if you want to compute, you can compute it as standard deviation of B square minus correlation between A and B into standard deviation of A into standard deviation of B, the whole thing divided by standard deviation of A square plus standard deviation of B square minus 2 into correlation between A and B into standard deviation of A into standard deviation of B. So this is the formula. Now I won't be able to derive you or give the logic for that because you don't have that mathematical backing right now. You have a bit of it, like, I don't know if you remember application of derivatives in your school days or in your college days, like 11th and 12th standard. Application of derivatives, there was a concept of minimization. So those who had the quantitative background, they'll be able to connect it. There was something called as, minimization and maximization of functions, right? Using that entire procedure of taking the first order derivative, second order derivative, then equating second order derivative with equal to 1, and then substituting it. That procedure is used to obtain this formula of weightage of A. Okay, so weightage of A, which is the minimum variance of the risk portfolio, we can use this formula to calculate a weightage of A, which will give us a minimum risk. So let us just substitute it and try to get the weightage. You can just substitute the numbers from here in this formula and just verify if you're getting this 0.659 and 0.341. Just verify it, guys, quickly. Please verify if you're able to, if you're getting this 0.659 and 0.341 as a weightage or weight of A to be creating a minimum risk portfolio. Just try to calculate this. Substitute the values over here. Is nothing but standard deviation of B square, which will be 13 square minus correlation of 0.2 into standard deviation of A into standard deviation of B. So just substitute and try to get the weightage of A. See if you are getting this weightage, guys. Getting? Are we getting it same? Yeah. So it will be like weightage of, standard deviation of B square minus correlation into standard deviation of A into standard deviation of B. That's the numerator. Denominator will be standard deviation of A square plus standard deviation of B square minus 2 into standard deviation of A into standard deviation of B into correlation between A and B. And if we just divide it, we're getting this as 0.659. Of course, if weightage of A is 0.659, weightage of B will be 1 minus 0.659. Yeah. Got it? So that's how we calculate the minimum variance or minimum risk portfolio weights. Okay. Let me quickly summarize what we have covered, the numbers, the total formula till now. Otherwise, we'll just get confused. First up, how do we compute the expected return of portfolio? Expected return of portfolio is computed as weight of X into return of X plus weight of Y into return of Y. How do we compute the standard deviation of our portfolio? It will be square root of weight of x square into standard deviation of x square plus weight of y square into standard deviation of y square plus 2 into weight of x, weight of y, correlation between x and y into standard deviation of x, standard deviation of y. This is what we have done. Then minimum risk portfolio, weight of x can be computed as standard deviation of y square minus standard deviation of x, standard deviation of y, correlation between x and y upon standard deviation of x square plus standard deviation of y square minus 2 into standard deviation of x, standard deviation of y, correlation between x and y. Got it, guys? This is the minimum risk portfolio. These are the only formula that we have done till now. Now, of course, if the R value changes, this formula will get modified. Are we good till now, everyone? Are we good? These are the only three formula that we have done originally. Just the substitution part is different. Yes, are we good? Shall we go for some questions now? Everyone? Let's go for certain questions from our assignment sheet, which will involve application of this formula. Okay. Question number 3, guys. Let's try to do this question number 3. Read the question for a minute, then we'll start. Okay, so Mr. A is interested to invest 1 lakh in the securities market. He selected 2 securities, B and D, for this purpose. The risk return profile of these securities are as follows. So there are 2 securities, B and D, where the standard deviation is given. Right? And the expected return is given. Coefficient of correlation is given to us between B and D to be 0.15. You are required to calculate the portfolio return of the following portfolios of B and D to be considered by A for his investment. So we require to calculate the portfolio return of B and D to be considered by A for his investment. First, 100% investment in B only. Second is 50% of the fund in B and the rest 50% in D. 75% in B, rest 25% in D, and 100% investment in D only. Also indicate that which portfolio is best for him from risk as well as return point of view. So this is similar to what we had, this sort of setup, right? So let me just sheet here. Okay, so the securities are named as B and D, and we have the portfolio values available with us. Coefficient of correlation, wait, B and D, we have the standard deviations to be 10 and 18. And returns are 12 and 20. The correlation is 0.15, right? And they have asked us to create 4 portfolios with 100% in B, 50% in B and D. So 100% in B, and of course 0% will be in D. Then next is 50% in B, 50% in D. So 50-50 in B and D we have 0.5, 0.5, Then it is 75 in B, 25 in D, 0.75 in B, 25 in D, 100% in D only. So if it's 100% in D, so this will be 0 and this will be 1. So in total, we want the calculation for 4 portfolios. Can we calculate this, guys? Applying this formula of portfolio risk and return. Can we calculate the portfolio risk and return now? Yes. For the 4 portfolios, the risk and return. Please go ahead and calculate it, guys. First, try to get the portfolio return because that's easy. And even over here, the first and the last one is pretty easy because it's just the 2 securities that we are dealing with, right? The other 2 requires, a bit of calculation. Please solve it, guys. Solve it. Get the values of standard deviation and return of the 2 portfolios, 2 and 3. Please calculate the standard deviation and the returns, guys. Returns can be computed very easily by just taking the weighted average numbers. The real thrill is in calculating the standard deviation. Okay, so this is 10.932. Okay, 10.93. Given the standard deviation for the third portfolio. And third is 9.31. Okay, perfect. So now, question asks us, indicate which portfolio is best for him from risk as well as return point of view. So from risk and return point of view, which of the portfolios are best suitable for him? Which of the portfolios are best suited for him? Yeah, tell me.
Third one?
Third one,
With
right?
9.31.
Yes, 9.31 and 14. This is the best suited because that gives us a 14% return with a risk of like 9.31. So as far as risk is concerned, third portfolio is better. And from the return point of view, if you are really giving a disregard to the return, from return point of view, of course, the fourth portfolio is going to be better. So if you want to minimize the risk, you should invest in third portfolio. And if you want to minimize the or maximize the return, then you should invest in the fourth portfolio. Okay, simple. Simple, guys. Shall we proceed? Yes. Okay. Let's look at these two. Now, question number 4. Question 4. Consider the following information on 2 stocks A and B, 2006 and 7 data is given. The return of A is like 10 and 16, and return of B is like 12 and 18. you're required to compute the expected return on portfolio containing A and B in the proportion of 40 and 60, standard deviation of return from each two stocks, covariance of returns, correlation, risk of portfolio containing 40 and 60. So it's a full-fledged question with just 2 data points. So we have like return of A and B. Let me write down A and B. So A is having a return of 10 and then 16. B is having a return of 12 and 18. Right. The expected return of A and B is 40 and 60. 40 and 60 weight is to be taken. Now, first we need to compute the expected return of A. So for that, obviously, we take the summation of A and B. Right. So expected return of A. Expected return of A will be simply average of A, which is like summation of A divided by N, or you can say 2. This is nothing but 26 divided by 2. Same way, what will be the expected return of B? So expected return of B will be summation B upon N. That will be 30 divided by 2, which is 15. So expected return of B will be 15. Then we have like weightage of A is 0.4. Weightage of B is 0.6. So what will be the expected portfolio return? Expected portfolio return. This will be weight of A multiplied by expected return of A plus weight of B multiplied by expected return of B, which will be equal to 0.4 multiplied by 13 plus 0.6 multiplied by 15. Right? So that will be 0.4 into 13 plus 0.6 into 15. That's like 14.2 is the expected return. 14.2% is the expected return. That's the first part. Then the standard deviation of the return from each of these two stocks. Standard deviation of return. Now, how do we get the standard deviation of return? That will be computed as A square and then B square. Between A and B, then we want to compute the standard deviation. I just need to take the square, and same applies for B also. That is like B square. Okay. So now standard deviation of A and standard deviation of B. Standard deviation of A. We know the standard deviation formula. So standard deviation is computed as square root of, since there are two securities possible, two values possible, we can say it is summation of A square upon N minus expected return of A. Right? So that will be simply square root of A square by N, which is 356 divided by 2 minus expected return of A. So expected return of A will be A divided by 2, sorry, expected return of A square. So this will be square it is square root of 356 by 2 minus not expected return, expected return is 13 square. So we get the standard deviation of A as 3, right? Then what's the standard deviation of B? Standard deviation of B will be also computed on the similar lines, which will be square root of summation of B square upon 2 minus expected return of B square. So that will be again 3. So both the securities are having a standard deviation of 3. Are we able to get this standard deviations, everyone? Are we able to calculate the standard deviations? Yep. Are you able to calculate the standard deviations, guys? Yeah. Okay. So standard deviation of A and B is done. So that's the second part. Then we want the covariance of returns between the two stocks. Now, how do we get the covariance? Covariance is computed as summation of X, or you can say this is A minus expected A multiplied by B minus expected B, the whole divided by N. So what we will need is 2 more columns here, which is A minus expected value of A, which is nothing but the average of A. Then we'll also need B minus expected value of B. So this will be like 10 minus expected value of A, which is 13. Again, A minus expected value of A, which is 13. For B, it is going to be 12 minus expected value of 15. And then it is 18 minus expected value of 15, right? And then what we have to do is multiply both the part, which is A minus expected value of A, this multiplied by B minus expected value of B, right? So we take a multiplication of both the things. Then we take a sum of it. So this is 18. So when you want to calculate the covariance, this will be 18 divided by the number of terms. The number of terms are 2. So this will be like 18 divided by 2, which is 9. Okay, so covariance is computed as 9. And then finally we have correlation between the two stocks. Now we know correlation is simply covariance between X and Y divided by standard deviation of A multiplied by standard deviation of B. So this is covariance upon standard deviation of A. Standard deviation of A was 3. And of course, again multiplied by 3. So the correlation number is 1. Correlation is 1. So once we get the correlation as 1, then they say the risk of portfolio containing A and B in the weightage of 40 and 60. Okay, so weightage is already given. So you can calculate portfolio risk to be simply weightage of A into standard deviation of A plus weightage of B into standard deviation of B. I can simply take a weighted average over here because the correlation is 1. So as the correlation is 1, we can simply take a weighted average of the standard deviation numbers. Right? Correct, guys? We can get the standard deviation numbers. Yes, so that completes our question number 4, guys. That completes the question number 4. Are we good, everyone? Question 4 easy. Now let's do question number 6, guys. Let's complete this question number 6 now. We have the information regarding the security returns, security 1 and 2. So 2 securities are given with their 10 returns available for us. We have to compute the covariance and the correlation coefficients. So we have like security 1 and 2. So let me name them as X and Y. We'll first write down the numbers, which is 12, 8, 7, and 14, 16, 14, 14, 16, 15, 18, 20, sorry, 15, 18, 20, 16, and 22. And Y is like 20, 22, 24, 20, 22, 24, 18, 15, 20, 24, 25, 22, and 20. So we have got this X and Y values. So we got the X and Y values. The question asks us to compute the covariance and the correlation. Now we know the covariance. Covariance, for computing covariance, we need X minus expected value of X multiplied by Y minus expected value of Y. So to compute the covariance, we can simply use that formula. Right. So let's say covariance can be computed as X minus X bar, Y minus Y bar divided by N. So first we need to get the X bar and Y bar values. Before we apply for covariance, we need to get the X bar and Y bar. So for that, we need to take a total of X and total of Y. The total of X and total of Y. That will give us the covariance, that will give us the X bar and Y bar. So we can say expected value of X, or the first security, will be 148 divided by, what's the number of observations here? 10. So the expected value is 14.8, and then the expected value of Y, will be computed as 210 divided by 10, which is 21. So now covariance, to compute covariance, we need to add columns of X minus X bar and Y minus Y bar. Right. So this is going to be X minus expected value of X, which is Y minus expected value of Y. Right. And of course, I need to multiply this, calculate the covariance. So this is going to be x minus expected value of x multiplied by y minus expected value of y. Right. So, expected value of x is 14.8 and expected value of y is 21. So, expected value of x will be subtracted from x value. So, this is 12 minus 14.8, then 8 minus 14.8, there will be 7 minus 14.8. So, you can just drag it on the similar way. And then same way we have to do the y minus expected value of y. So y minus 21, y minus 21, again y minus 21. So throughout we are going to subtract the expected values to arrive at these terms. And then we just need to multiply these terms and take a summation of it. Okay, so that's like minus 0.8, right? So covariance will be essentially, if we apply or write down the formula, it is summation of x minus expected value of x into y minus expected value of y. Right? And then this whole thing divided by number of terms. So this is nothing but minus 8 divided by 10. This is simply minus 8 divided by 10 minus 0.8. Right? So covariance is minus 0.8. Now we can get the standard deviation also. Standard deviation of x and of course standard deviation of y. Can we compute the standard deviation of x and y and then the correlation? And then the correlation will be simply covariance between x and y upon standard deviation of x multiplied with standard deviation of y. So this will be covariance is minus 0.8. You divide it by the standard deviation numbers, you will get the correlation. Okay. Now to compute the standard deviation, since we have already done like x minus expected value of x and y minus expected value of y, we can simply say it as this term, which is x minus expected value of x square, like x minus expected value of x square. And same way we can have like y minus expected value of y square. So we'll take a square of the deviations, square of deviations. So take a total, and same applies for y also. So for y also you do the same thing. And we know it is standard deviation, which is the taking into account this aspect. So standard deviation of x, the formula for standard deviation of x is square root of summation of x minus expected value of x, the whole square, upon n. So now the calculation over here will be square root of variance, the square root of the deviation, sum of square deviations, and you divide this by 10. So we get the standard deviation as 4.55. Okay, standard deviation is 4.55. Second standard deviation, we can obtain it in a similar way as square root of 84 divided by 10. That's 2.89. Okay. Then finally correlation will be like minus 0.8 divided by 4.56 into 2.90. This will be minus 0.8 divided by 4.56 into 2.90. So the correlation is extremely low, which is minus 0.06. Okay, so correlation is extremely low, which works out to be minus 0.06. Okay, so that's how we compute the correlation, covariance, and the standard deviation of the securities. So now let's take a break, guys. So take a break. If you want, you can just solve this. I know you might have not completed this question fully because I have solved it using Excel. So you need to do the calculations. I can understand it. Okay, but the only way to take the things forward would be looking at the concept and not getting involved in the calculation part, right? So let's take a break now, break of 10 minutes, and then we'll come back with discussion on some more concepts about this. Okay, let's take a break, guys. we have done this question 6 now. Then we have to look at this question number 7. Question number 7, an investor has decided to invest rupees 1 lakh in the shares of 2 companies, namely ABC and XYZ. Projections of the returns on the shares of the 2 companies are given along with the probabilities. So we have to comment on the return and risk of the investment, compare the risk and return of the 2 shares with a portfolio of these shares in equal proportion. So with equal weightage, what will be the risk and the return? And second, find out the proportion of each of the above shares to formulate the minimum risk portfolio. Now, of course, to create the minimum risk, portfolio, we need to essentially compute the correlation between the 2 securities also. So let me just take down the data here. We have the probability and the ABC return and XYZ return. ABC and XYZ. Okay. So probabilities are like 0.2, 0.25, 0.25, and 0.30. ABC is 12, 14, 7. So minus 7. 14 minus 7, then 28. And then XYZ is like 16, 10, 28. 8 and minus 2. So these are the probabilities and XYZ and ABC returns given to us. The question asks us what should be the return risk of the individual shares. Now to compute the risk and return, we have to use the same standard deviation formula and the weighted average numbers. So if you want the expected return of ABC, that will be simply summation of probability multiplied by the ABC numbers, right? So summation multiplied by probability of probability into 80 numbers. So we have said the probability multiplied by ABC. So the probability numbers multiplied with ABC, we can get these numbers. Take a total. That gives us 12.55 to be the expected return. 12.55 to be the expected return. Right. Same way, to compute the expected return of XYZ, compute the expected return of XYZ, we can take summation of probability into XYZ. So we can calculate the numbers probability into XYZ and then take the total. Now, give me the total. Give me the expected return of XYZ. Give me the expected return of XYZ, guys. This will be computed simply as probability multiplied by XYZ. Then we take a summation. So the return is 12.1%. I'll just give you maybe 3 or 4 minutes to calculate the standard deviation of these 2 securities, guys. Calculate the standard deviation of these 2 securities. Standard deviation of these 2 securities. To compute that, what we'll need is first ABC minus expected value of ABC, or we can say average of ABC, and then we need to just multiply probability with this term, which is ABC minus expected value of ABC. But this needs to be square. Same way, you have to do it for XYZ also. This is going to be like XYZ minus expected value of XYZ. This is probability of XYZ minus expected value of XYZ square. Yeah, calculate these values and give me the standard deviation of ABC and also the standard deviation of XYZ. Standard deviation of ABC and standard deviation of XYZ. Calculate these guys quick. Give me the values for standard deviation of ABC and standard deviation of XYZ. And then we will proceed further. Yep. Calculate the values by standard deviations. So ABC return minus expected value of ABC, which is 12.55. Right. Then we take a sum. Another sum is not required. Next is to compute the ABC square. Further multiply it with probabilities. We need a summation of it. Right. So this is simply going to be square root of probability into ABC, square root of probability into ABC minus expected value of ABC, the whole square. Right, so this will be simply square root of 167.75, which is 12.95. Okay. Now, same way, get the standard deviation for XYZ also. Get the standard deviation numbers for security XYZ also. Get the standard deviation for XYZ also, guys. Yes. So next one, 11.27. Okay. So XYZ minus expected value of XYZ, which is 12.1. Just drag it down. And then XYZ into XYZ, this multiplied by again this into the probability. This 126 point. Right? So this will be simply square root of 126.99 to 11.27. Okay. 11.27 is the standard deviation of XYZ. Okay, so that part is done. Now, compare the risk and return of these two shares with the portfolio of these shares in equal proportion. So risk and return of a portfolio. Now, how do we calculate the portfolio return? Portfolio return will be simply weighted average. But for portfolio risk, can I take a weighted average? Can I take a weighted average for a portfolio risk? To calculate the portfolio risk, can I simply take the weighted average of the standard deviations? Yes. Can I simply take the weighted average of the standard deviations for the
Yes,
portfolio
if for
standard?
correlation,
Yes,
R
we
is
have
there.
to compute the correlation, right? So before we go for portfolio risk, we need to compute the correlation. Now, what is the formula for correlation for this type of probability data? Now, the formula remains the same, which is covariance upon the standard deviation, right? So correlation over here, it's going to be the same formula. Now, covariance over here is computed as summation of probability into x minus x bar or expected value into y minus y bar into which is the expected value, and then you divide it by standard deviation of x and standard deviation of y. Now, of course, we don't have x and y, so I need to rearrange. I need to rewrite this as this is ABC minus ABC, and this is XYZ minus XYZ average. Then standard deviation of ABC multiplied by standard deviation of XYZ. Okay, so this is equal to now summation of P into ABC minus ABC bar and XYZ minus XYZ bar. So I need to add that column here, right, which will be probability into ABC minus expected value of ABC, this multiplied by XYZ minus expected value of XYZ. Right, so this will be computed as probability multiplied by ABC minus the expected value multiplied by XYZ minus the expected value, and then we take a total. So this is to be computed for computing the correlation. Okay. So probability into the deviation of both the securities multiplied. So this is our numerator, which is 144.26. Denominator has a standard deviation of 12.95 and 11.269. Okay. So what will be the correlation number? It will be 1 minus this divided by 12.95 and 11.269. So we get this as a negative correlation of minus 0.99. Okay, so that's the correlation number. That's the correlation between the two securities ABC and XYZ over here, which gives us a correlation number of minus 0.99. It's almost minus 1. Now the question asks us to compute the risk and the return. Now, I have given you this portfolio risk, right? Portfolio risk is given to you. You have the return of ABC, return of XYZ, standard deviation of ABC 12.95, standard deviation of XYZ 11.27, and you have the correlation. The additional thing that we need over here is weightage. So weightage of XYZ is 0.15. Weightage of XYZ is equal to 0.5, and weightage of ABC is also 0.5. Then we want to compute the portfolio risk and the return. Portfolio return we can compute is simply weighted average, right, which will be weight of ABC into return of ABC plus weight of XYZ into return of XYZ. So that's 12.325. Now I want you to calculate the portfolio risk. Give me the portfolio risk numbers, guys. Give me the portfolio risk numbers. Portfolio risk, can we compute it? Because we know the standard deviation, we know the correlation, and we also know the weightages. So I think we should be able to compute it. Yep. So what's the portfolio risk? Portfolio risk, guys. Compute it using Markowitz formula. Compute the portfolio risk using Markowitz formula, guys. So Markowitz formula, using Markowitz formula, portfolio risk will be is equal to square root of weight of ABC square into standard deviation of ABC square plus weight of XYZ square multiplied by standard deviation of XYZ square plus 2 into weight of X and weight of ABC into weight of XYZ into standard deviation of ABC into standard deviation of XYZ into correlation between ABC and XYZ. So the portfolio risk is like 1.2477. Right, so portfolio risk is 1.2477%. That's the portfolio risk. Okay. That's simply the portfolio risk. When you have the weightage as 0.5, 0.5. When you have the weightage to be 0.5, 0.5, then they have this portfolio risk to be 1.2477. Okay. Then the next part of the question is find out the proportion of each of the above shares to formulate a minimum risk portfolio. You remember the minimum risk portfolio formula? Minimum risk portfolio. You have to compute, let's say, weightage of ABC. Weightage of ABC. How do we compute the minimum risk portfolio for weightage of ABC? It will be standard deviation of XYZ square minus standard deviation of ABC into standard deviation of XYZ into correlation between ABC and XYZ, the whole divided by standard deviation of ABC square plus standard deviation of XYZ square minus 2 into standard deviation of ABC into standard deviation of XYZ into correlation between ABC and XYZ. Yeah, so compute the weightage. Compute the weightage of ABC, guys. We have the numbers, right? We have the standard deviations. We have the standard deviations. And we have the correlation. You just need to substitute here and give me the weightage. Give me the weightage, guys. Weightage of ABC. Substitute in this formula and give me the weightage. Yep, substitute and give me the weightage, guys. Yep, substitute and give me the number, guys. Give me the weightage of ABC, which will result in, of course, the minimum risk portfolio. How much is it? First up, variance of XYZ. So this will be this square minus standard deviation of ABC into standard deviation of XYZ into correlation divided by standard deviation of ABC square plus standard deviation of XYZ square minus 2 into standard deviation of ABC into standard deviation of XYZ into correlation. This will be like 271 divided by 583.4650. This is weightage of ABC. So obviously then weightage of XYZ will be 1 minus 0.4651, which is equal to 1 minus 0.4651, 0.5349. So weightage of XYZ is 0.5349. Okay. Yep. Yeah. Hello, Rakesh.
Sir, in case of that 50-50 scenario, while multiplying R, coefficient of correlation, should we ignore the minus sign or
no,
because
that
here
will be,
we have not ignored?
No, that will be minus sign, of course, because I have linked it with minus 0.99, so that automatically becomes a negative number.
Okay.
Okay. So it has to be minus sign because only then the portfolio risk will get reduced.
Okay.
Right.
Thank you, sir.
Yeah. Yeah. Okay. So we are done with this question number 7. Now, the 6th is also done. Let us understand something called as efficient portfolio or efficient security and inefficient portfolio, inefficient securities. Let's understand that. And then based on that, we'll have this particular question. And one of the theories, which is a Markowitz model portfolio theory that we're going to discuss. Efficient and inefficient securities. Efficient and inefficient securities. Now, what do you mean by efficient and inefficient securities? The Markowitz, that's modern portfolio theory, father of modern portfolio theory, has set out a very simple rule for identifying the efficient and inefficient securities. It says, the theory says, a security will be inefficient if there is some other security which provides three situations, which provides. So security, we are going to say that a given security this Ginny. In this formula, risk portfolio, we always take second security as numerator. Why not first one? Because that's a derived one. So mathematically, it has been derived. So there is no simple logic to this because this is derived using the application of derivatives. So there, the derivation itself comes out to be like this. It's not that always EB, that second security is to be taken in the numerator and not in the. No, that simple logic or simple common sense doesn't apply always, right? So these are like higher level of mathematical calculations that are undertaken. Okay, so this by default, the formula itself is as it is, that we need to keep it in the numerator in that. Okay, coming back by. So security will be inefficient if we are going to say that a security will be inefficient if there is some other security which provides higher return at lower risk. So tell me, if you have some other security, if there is some other security or portfolio or possibility where you can earn a higher return, but at a lesser risk than this, obviously you will invest in that security. Am I right, guys? Yes or no? Correct? So for example, if we have risk and return of our original security, let's say risk is 10% and return is 12%, right? So if we have the other security, other security is risk and return. If you have the other security as, let's say other security is, having a risk of 8% and a return of, let's say 13%. So can I say, in comparison to this, the other security will be preferred, right? So obviously we as a normal investor, as a rational investor, would like to invest in this other security where the risk is lower and return is also higher. And therefore we say that the given security is inefficient. So the given security is said to be inefficient, right? Now, one more way by which we can say that the given security is, inefficient. If there is some other security which provides you higher return at same risk. So if there is some other security which provides higher return at same risk, for example, if there is another security which is having the same risk as 10%, but it gives you a return of, let's say 14%. So can I say, would you be invested in the original security? Would you be invested in the original security, or would you like to shift your investment to the other security? Of course, to the other security, because it gives you at the same level of risk a higher return, right? And the third rule by which we'll say that a security is inefficient is it provides the same return at lower risk. So it's quite likely that it provides the same return at lower risk. So same return is, let's say, providing you, 12% return. So it is like providing you 12% return, and the risk is lower, let's say 8%. Risk is lower, so let's say 8%. So in comparison to them, our security is inefficient. So I'll just try to put up a chart in front of you so that we will be able to, understand it more clearly. Yeah, look at this security, guys. Look at this particular chart. You can see that these securities, the three securities are efficient as compared to this one, right? The upper security provides you higher return at same risk. This provides you same return at lower risk. And of course, this gives you a higher return at lower risk. So in either of these cases, we would like to be invested in any of these three securities, right? Rather than staying invested over here. So that's how we identify the inefficient security. So this is our inefficient security. This is the inefficient security. And the set of all the efficient securities, is said to be efficiency frontier. Okay, all the efficient securities are said to be combining together, and the entire line that is formed by efficient securities is called as the efficiency frontier. So any security which is lying below the efficiency frontier, will be said to be inefficient security. And the rules are pretty clear. It should provide you higher return at lower risk, higher return at same risk, or same return at lower risk. Okay, so are we good? Are we clear enough to understand what is an efficient security and what is an inefficient security? Inefficient securities, we have got these three rules. For the efficient securities, we can say whichever securities which are not inefficient, they will be obviously categorized as efficient securities. Clear? So let's apply this rule now. Let's simply apply this rule to one of our questions, which is question number 5. Okay, let's apply this rule to question number 5 first. So we have like securities, let me write it down. A, B, C, D, E, F, right? And there we have like risk and the return. Let me do one thing. I'll write the risk and then the return. Yes. So risk is like 8, 4, 8, 5, 12, 4. Sorry, 4, 5, 12, 4, 4, 5, 12, 4, 5, 6. And return will be 8, 8, 12, 4, 9, 8. Okay. Now we have to identify that out of these securities which are efficient and which are inefficient, right? So we'll write down the name of the securities, and then we will say it is inefficient to, and the reasoning for that. Okay, like securities A. Is security A inefficient to any other security? Is the security A inefficient to any other security?
No.
No? Because security A is having a risk of 4. To check, is there any security which is having higher return at lower risk? There is no risk which is lower than 4. Is there any security which is providing you same return but at lower risk? No. Is there any security which provides you higher return at the same risk? No. So it is inefficient to none. Then look for security B. Is it inefficient to any security? Is B inefficient to any security? Compare it with A. Right? A has got a lesser risk, but same return. So we can say it is inefficient to A. What will be the reason that I will give over here? What will be the reason? A gives same return at lower risk, right? Okay. And is it inefficient to any other security? Like, is there any other security with the same risk? Yes, sir. There is a security which is there with the same risk. And what's the return? 9. So can I say it is inefficient to E because E gives, what does E give? E gives higher return
Higher return
at same risk, right? Then any other security which is efficient as compared to B? Is it efficient to C? No, C is having a higher risk, but same return. So B is not inefficient. B is not inefficient as compared to F because it is giving you same return at higher risk. So B is not inefficient because B is providing you 8% at 5% return. So B is actually efficient as compared to F. You can say F is inefficient to B. Got it? So B is having a lesser risk. So it is not inefficient. Now coming to C. C is inefficient to what, guys? C is inefficient to, is it inefficient to anyone? Is there anyone with a risk of less than 12? There are all which are having less than 12. But is there anyone who's providing you a return? Is there any security which is providing you a return more than 12? No. So it is actually inefficient to none. Okay. So it is inefficient to none. Then coming to D. Is D inefficient to any security? Yes, sir. D is definitely inefficient to security A. Why so, sir? Because A gives higher return Yeah. So we can say here, A gives higher return at same risk. So D is of course inefficient to A. Okay. Is E inefficient to any security? Is security A, E inefficient to any security? Is there any security which provides less than 5% risk? Yes. But is there return more than that? No. Lesser risk is not there, same risk is there, but the return is also lower. So here we say E is inefficient to none. Then security F. Is the security F inefficient to anyone? Yes, it is inefficient to A because A gives same return at lower risk. A provides the same return at a lesser risk. Is it inefficient to any other security? Yes, it is inefficient to B because B gives again same return at lower risk. Then, is it inefficient to any other security? Yes, it is inefficient to E also because E gives higher return at lower risk. Higher return at lower risk. So which of these securities are inefficient? Which of these securities are inefficient? Securities B, D, and F are in total inefficient. And if you want to check, which one of them are inefficient graphically also, we can understand this by way of a scatter plot also. So you can observe that there is this curve coming over here. All right, so these are the inefficient securities. I mean, the inefficient securities are like, how is this getting formed? Yeah, same line, A, B, C, D, E, F. One, 1.5, I don't know. What are they really talking of? Anyways, forget it. So if you just try to plot this, you can see B, D, and F are inefficient securities. So B, D, and F are inefficient securities. How is B inefficient to E? How is B inefficient to E? Because B is having the same risk. I mean, the security E is having the same risk, 5. Return is higher. Return is 9.
No, sir. Okay.
Return is higher. Same risk, but return is higher. So, of course, I would prefer to invest in E. So, B turns out to be inefficient. Okay. Then, next. Assume a perfect correlation. Show whether it is preferable to invest 75% in A and 25% in C, or to invest 100% in E. Okay. So there's a perfect correlation between C and E. Now, of course, C and E both are efficient securities. So with regards to C and E, we have the risk number and also the return. So C has got a risk of 12, E has got a risk of 5. C has got a return of 12 and E is having a return of 9. Okay. And then we have seen that 75% in 75% in A and C. Sorry. So this is not C and E. It's between A and C. Okay. The security A is having a risk of 4, return of 8, and C is having a risk of 12 and 12. So both A and C are definitely the efficient securities. So A and C with the weightage. Weights are given to us as 0.75 and 0.25. So weights are 0.75 and 0.25. Right. So risk is this number. Then they're asking us to compare it with the security E, which is having a return of 9 for a risk of 5. So, okay, the risk is 5, return is 9. So, first we need to compute the portfolio risk. Now, we know portfolio risk. For the purpose of portfolio risk, we need the correlation number. What is a correlation number given to us? So, correlation number given in the question is like perfect correlation. So, when you say perfect correlation, of course, we are talking of correlation being equal to 1, right? So, for a perfect correlation of 1, what should be the risk and the return? So, if it's correlation between A and C is 1, perfect correlation. So, if it's perfect correlation, how can we compute the portfolio risk, guys? Portfolio risk. Should I use the entire Markowitz formula again? Or do we have a shortcut for that? Since the correlation is 1.
You can use the weights.
Weights, directly weighted average, right? So you can say it is weight of A multiplied by standard deviation of A plus weight of B into standard deviation of B. So this will be weight of A multiplied by standard deviation of A plus weight of B into standard deviation of B. That is 6. Portfolio risk turns out to be 6. Let's look at what is the portfolio return. So portfolio return will be also weighted average, which will be weight of A into return of A plus weight of B into return of B. which will be 0.75 into 8 plus 0.25 into 12. So we are getting that as 9. Correct? So this portfolio of A and C is giving us a return of 9% with a risk of 6%. So would we be preferring to invest in this portfolio, or would we be preferring to invest in the security E? A combination of A and C, is it better than the security E?
E is better.
E is better. Yes. Yes, E is better because there we find that the returns are remaining same, but less is the risk. So we can say security E will be preferred as compared to portfolio of A and C, as it gives same return at lower risk. Okay, so E is going to be preferred. Okay, so we have done quite a few concepts in today's class. We have, let me just quickly recap. So we have learned how to compute. Of course, the standard deviation was covered in the previous class, but today we started with the discussion about how to compute the covariance. So covariance was basically together variance of x and y. So it's simply summation of x minus x bar into y minus y bar divided by n. That covariance was used to calculate the correlation between the securities by simply dividing the covariance with the two standard deviations, right? And then after that, we learned something called as the Markowitz portfolio theory, modern portfolio theory, portfolio risk measurement, which was having two of the formulas where we can use the covariance or we can use even the correlation term. So this was weight of x squared, standard deviation of x squared plus weight of y squared into standard deviation of y squared plus 2 into weight of x into weight of y into, you can use covariance, or you can have like standard deviation of x, standard deviation of y, and correlation between x and y. Then to get the optimum portfolio, we came up with this formula to calculate the optimum portfolio weights, which results in the lowest risk of the portfolio, right? So this was like, if I wanted a weightage of A, that will be standard deviation of B square minus correlation between A and B into standard deviation of A and B, and then divided by standard deviation of A square, or variance of A square plus variance of B square minus twice the same term as a numerator. Okay, then after that, we went ahead and also identified the securities. I mean, we did the same calculation for probability-based data. And based on probability data, also we computed the risk and return. And then we finally learned about the efficiency frontier and the efficient and inefficient securities with the rules already set by Markowitz, that efficient securities are those which are inefficient. Now, how do you identify which one is inefficient? So that provides you, if there is another security which provides you higher return at lower risk, or higher return at same risk, or same return at lower risk, then you say that the other security is efficient and the given security is inefficient. And then we completed this typical question as a practice for efficient and inefficient securities. Okay. Now, do we have any queries to discuss? Yes. Any set of queries you have in our today's discussion? No? All clear? Okay, fantastic.
Jagbandu ji?
Yes, sir.
I think you have checked the query ender also, na, as well.
Yeah.
Okay. Okay, student. I think with this we come to the end of this session. And Jagbandu sir, I really thank you because you have made understood the topic of correlation to the student in a very good manner, because you have taken the various cases, like if the coefficient of correlation is 1, then the
think we have lost you, sir. We have lost Ashish, sir. Connection lost, I think. Sir won't be able to join, so let me just end the session. So if you have any queries, you can just access us easily via this number and the email ID. Okay, so we'll meet up again on Wednesday with the next set of discussions. Okay, let's stop here, guys. See you in the next session. Bye bye. Yes. Thank you.